Okay, guys, here we are. Last formal notes lesson of the year in calculus. Woohoo! You made it. You made it. Let's go ahead and look at these. Once again, this is the chain rule with trig. I really want you to concentrate mostly on the first couple of examples, but I provided and that's what the homework problems are like examples 1 and 2. But I provided other examples as well to show you another way that trig is used. So mainly examples 1 and 2 is all you need. But I want to provide you with the information for 3 and 4, so if you're in a calculus course next year, you've at least seen it. Okay, so for this particular example, what I have is I've got a trig function. I've got a single trig function. And so what I'm going to do is I'm actually going to choose my u to be what's inside of that parenthesis. And I know there technically is a parenthesis on your notes, but it's what, in this case, follows the cosine. So I'm going to say u equals 5x. Well, the derivative of that, the derivative of 5x is 5, and we would say 5 dx. Now, if I look at my integrand here, I have the 5 and I have the dx. So what I've underlined in green actually becomes du. And I have the integral of the cosine of 5x is u. So I have the integral of the cosine u du. Well, the integral of the cosine, we know, is going to be the sine. So it's the sine of u plus c. And again, the last step is to replace u with what it was up here. So that would be the sine of 5x plus c. So that is our answer. And if you're not sure of that, think about what would happen if you took the derivative of that. Well, the derivative of the sine of 5x, you don't have to do I'm doing it yellow, it's just me checking my answer. The derivative of the sine of 5x is the cosine of 5x. Chain rule says take the derivative of what's in the inside, which would be 5. So you'll notice that that will match exactly what we started with, which was 5 times the cosine of 5x. So those two match, and so you can always check your answer by taking the derivative of what you found. So take a look now at example 2. I'm going to say u equals x to the 4th. The derivative of x to the 4th would be 4x cubed dx. That's nice. I have 4x cubed. I have dx. So everything underlined in green becomes du, or is replaced or substituted out for du. That's why it's called substitution. So now I have the integral of the sine. X to the 4th is what I assigned u to be. So to be the sine of u du. The integral of the sine of u would be the negative cosine of u plus c. And again, the last step, as always, is to replace u with what you found it or assigned it to be in step 1. We move on to example 3, which is, again, kind of a traditional thing. What I'm going to do is I'm going to rewrite this, and I'm going to leave myself a little bit of space here so you can see how this is going to switch. My u, once again, is going to be what follows my trig function. A lot of times guys see secant squared, they start to get a little intimidated. Don't let it intimidate you, just follow the path, right? So if u equals 10x, the derivative of u is going to be 10 dx. Now, unlike examples 1 and 2, I have my dx, but I don't have a 10. So what I have to do is I have to put a 10 on the inside, and to compensate for that, like we've been doing in the past, put a 1/10 on the outside. So now the 1/10 comes straight down. This will be the integral of what I've underlined here in green. That becomes du. And then I'll simply have the secant squared of u du. Well, what is the integral of the secant squared? In other words, the tangent of what is secant squared? The derivative of what is secant squared, and that would be the tangent. Gave away the answer there. And so now the last step would be to plug in our u, which is 10x, plug 10x in for u, and there we have our answer. If you were to take the derivative of that, the derivative of the tangent of 10x would be the secant squared of 10x. Chain rule, the inside would be 10, but because that 1/10 they would cancel, which is why we don't have a coefficient in the original. Okay, guys, so this is a part of the video that is an extension to where, what do you do if you have multiple trig functions? Now, I didn't give you any like this on the homework. So really, this is just kind of extra info for you. In this case, if I allowed u to be what was in the parentheses, which would be x, du would be dx, and really, when I would replace the x's in the d with u and the du with dx, I would get the same exact thing. It doesn't simplify it. When you have multiple trig functions, a lot of times what happens, not always, but often, what happens is one of those trig functions, the one that's taken to a power, is actually what u is. So instead of u being what's in the parentheses, u would actually be the sine of x. Well, the derivative of the sine of x would be the cosine of x dx. So when I look at this part underlined in green, that becomes du. When I look at the sine of x is u, and it's being taken to what power? The fifth power. So what's the integral of u to the fifth du? U to the sixth over 6 plus c, which, when I replace u with the sine of x, that would be sine to the sixth power of x over 6 plus c, or 1/6 times the sine to the sixth power of x plus c. So this is a slightly different variation where the u is actually a trig function, not what's in the parentheses that follows. Now I will tell you, all the homework questions tonight are like examples 1 through 3. They are not like this example where you have to assign a trig function to be used. So I kind of kept it simple on the homework tonight since this is the last one, but I can almost guarantee that you'll see this next year in a calculus course. So now the very last example of the year, woohoo, last example. We look at this and you go, well, Mr. Ashby, in this case, I've got the tangent, which is being taken to the 1/2 power, and the secant squared, which is being taken to the second power. So unlike the previous example where it was obvious which one was u, this one is a little tougher. So in this situation, you would ask yourself, well, is there one of these that is a derivative of the other? And if you know your derivatives, you know the derivative of the tangent of x is the secant squared of x. So I'm going to choose my u to be the tangent of x. Well, what's the derivative of the tangent of x? Well, the derivative of the tangent of x is secant squared of x. So dx. So everything underlined in red here, that becomes du. The tangent of x, that's u, right? So that becomes u to the 1/2 power because the square root is to the 1/2 power. And so now when I integrate that, that'll be u to the 3/2 over 3/2, or 2/3 u to the 3/2 plus c. And so that'll be 2/3 the tangent to the 3/2 power of x plus c. Last example of the year, guys. That's a good one to end on. It's been great teaching you. We'll talk a little bit more. There'll be a quiz Tuesday, and then there will be an assignment Wednesday. Although it won't be any new calculus notes, there is a small assignment Wednesday. So don't skip class Wednesday. And have a great day.